This video looks at how you can find the equation of a tangent to a curve at a given point. Now a tangent is a straight line, so it's given by the equation y minus y1 equals mx minus x1. So to find the equation we have to know the gradient and a coordinate. Well, we know the coordinate, we just don't know the gradient yet. However, to find the gradient we find dy by dx, which is 3x squared take away 5. That's the general equation for the gradient. Now we know that x equals 1, so when x equals 1, the gradient will equal 3 times 1 squared, which is 3, take away 5, which is minus 2. So the tangent shares the same gradient by definition, so therefore m must equal minus 2. So y minus y1, y minus minus 4, so y plus 4 must equal m, which is minus 2, x minus x1, which is 1. So I can expand this. Y plus 4 must equal minus 2x plus 2. I can rearrange. Y must equal minus 2x, take away 4, minus 2. So we've found the equation of the tangent to the curve. Now this is where the tangent will just touch the curve, but that same line might hit the curve somewhere else. And part 2 talks you how to find where that tangent line hits the curve again. And we've got to find, therefore, where this line and the given curve intersect. Well, to do this, we use simultaneous equations. They must equal each other, so therefore x cubed take away 5x must equal minus 2x take away 2. So if I add 2x and add 2, this tells us that x cubed minus 3x plus 2 must equal 0. So therefore I've got to solve that equation to find where the tangent hits the curve. And I've shown the desired result from the question. So where the tangent hits the curve, this equation is satisfied. But that's the point. How do you solve that equation? Well, there are various methods to do for this, and I'm going to go through one such method. Now we know that one such solution is x equals 1. That was a solution to where the tangent hits the curve, by definition. So if 1 is a solution, then x minus 1 must be a factor. So x minus 1 must be a factor of that equation there. So I can divide this equation by that factor to get a simpler equation to then try and solve. Now I divide in my own particular way. I write x minus 1 down like so. I put my x cubed in my top left box, and I go, right, to get an x cubed requires an x squared, but minus 1 times x squared is minus x squared. I want there to be no x squareds, so we need a plus x squared. I've got an x here already, so we need another x on top to get an x squared. Then minus 1 times x is minus x. I want minus 3x, so I put a minus 2x in here. There's an x here, so we need a minus 2. And minus 1 times minus 2 is indeed plus 2 as required. So one factor is x minus 1, the other factor is x squared plus x minus 2. So that equation there can be written as x minus 1, the first factor, x squared plus x minus 2, the second factor, equals 0. That factorises even further to plus 2 and minus 1. Because 2 times minus 1 is minus 2, 2 take 1 is 1, so therefore my solutions are x equals 1, x equals 1, and x equals minus 2. So our other solution, other than x equals 1, is x equals minus 2. It is no surprise that x equals 1 occurs twice. The tangent is where the line just touches the curve, and therefore you should expect a repeated root. This is our other solution, which the question wanted us to find, i.e. x equals -2.